demonstrate the requirements for natural selection to occur, your book uses the example of the three-spined stickleback, a small fish that lives in freshwater lakes. And the fish is covered partially to fully with bony armored plates. So you have some fish that are lightly plated, some fish which are very heavily plated, and that plating is determined genetically and set at birth. So whatever happens in terms of the fish with small amount of armor plating versus large amount of armor plating is determined by its genetics at birth. We're going to look at an example of what happens under two different conditions. So we have a lake, in this case Lake Adams, that contains our sticklebacks, which are these guys here, and it also contains a predatory fish, the cutthroat trout. Now the cutthroat trout will pick preferentially those fish that have fewer bony plates, but when we look at the lake to start our simulation here, our lake is very polluted and murky, and so our cutthroat trout can't actually see who it is that they're attacking. When we look at our fish, our sticklebacks, we have this as the distribution of the number of bony plates. So the more bony plates, the more heavily armored they are. And this is the way that it will work when we look at all of our simulations. With the proportion of fish here, this represents how many or the amount of the sticklebacks that have a certain number of bony plates. When we look at our population, when we start here, we can see that the majority of them have a small number of bony plates versus a very small percentage that have the large bony plates. When we run it just as the model is with the murky water, we can see that there is change going on, that we have the fish swimming around, our cutthroat trout are eating some of the sticklebacks, but if we look at the pattern overall, we notice that things don't change much. So we're seeing very little change in the overall pattern, with most of them still being on the small end in terms of number of plates. We can also run this after the lake has been cleared up. So now there is the predator fish are able to see their prey, and they're able to go after the ones that are going to be easier to eat. In this case, that should be the ones with fewer bony plates. If we run the simulation now and watch what happens to our distribution, you'll notice that over time we have a larger and larger proportion of the population having more bony plates. And that's because natural selection is at work here. That with the predator fish being able to see who they're eating, they're going for the ones that are easier for them to catch and eat. Now, we have three different assumptions that we make when we look at the process of natural selection. One of them is that the population is variable. And you'll notice that when we started with, there were different numbers of bony plates. We can eliminate that as an assumption, and we can see what happens if the population is not variable. So in this case, we're starting with every individual having the same number of bony plates. And if we run the simulation now while it's murky, you'll notice that there is no change. If we switch the simulation so that the water is clear, there is still no change. So if we have no variability in the population, there is no variability for natural selection to act upon. Without the variability, we have no natural selection, and without natural selection, our population does not change.